all the participants of the 6th week of Adjunct Professor lecture series with the topic of smart energy and digital transformation. This event is held by Department of Information Systems, Faculty of Intelligent Electrical and Informatics Technology. I would like to welcome Prof. Shuo-Yan. Prof. Chou always show a great energy every week. Thank you for that.
You're most welcome. It's delighted to have the opportunity to share, exchange on these topics. Hopefully, the lectures can benefit some of you, and hopefully that we have future opportunity to have more exchange or even cooperation. Thank you.
Okay, thank you.
Thank you, Professor Chou. So today is already the 6 weeks, which is the closing of this year Adjunct Professor lecture. And we will have Professor Chou again next week. No, next year, I mean.
Next year, right.
Next year. Also, good afternoon to Dr. Mujahideen, the head of Department of Information Systems.
Okay.
And also good afternoon to Pak Indi Dewa Barata, who will lead for the exam. We have evaluated for today. Right. Before we begin, let me show the meeting rules. You have to fill the presence form, and please give your feedback as well in the presence forms. Use your full name in the Zoom meeting as well. And if you have any question, please raise your hand, or you can write in the chat room. There's also a certificate of attendance who will be available, and also another certificate who passed the evaluation. This is the schedule for today. We already have the openings. Then we will directly start the lecture about 1 hour after this, followed by the question and answer. Please ask questions before the final exam. So you will have 1 hour multiple choice as the final evaluations. And also I would like to remind about the mini project that the submission deadline is 4th of July, and then we will have the closing. The Adjunct Professor Program 2021, ITS is really proud to have this program. The aim is to be active in the international academics. And we have interesting topics throughout the lectures, start from foundation of Internet of Things, the IoT applications, digital fusion, Industry 4.0, smart manufacturing, and today we have smart energy and digital transformation. Prof. Shuo-Yan currently is a distinguished professor and director of Center for Internet of Things Innovations from National Taiwan University of Science and Technology. His interests include the Internet of Things, smart city application, and digital manufacturing. Without further ado, let's welcome Professor Chou. The time is yours.
Thank you, Rarang. Okay, let me share the okay. Can you see my screen and hear me?
I see.
Okay, perfect. So this is the time does fly. This is the 6th week of the lecture. I think I'm getting used to Thursday afternoon coming to my office and sharing some of the recent development on digital technologies. Again, my area is Internet of Things application. So all of the applications that I talk about involve getting data from the physical world. And the purpose is to helping us to manage the physical world well. So we have looked at other application problems as Raras has indicated. And of course, there are even more problems that we can look at. but due to the limit of time, so today also the time will be tighter. So I have already pre-selected some slides that I will go through. The first topic will be on the smart energy. Okay, so smart energy, well, when we talk about energy, there are two sides. One is from the supply side, one is from the demand side. And from the supply side, it's basically the power company or power producers. From the demand side, there could be many parties, but basically people like us, office, school, hospital, all these entities are from the demand side. So from the supply side, you can imagine that we want to supply more efficiently or effectively. From the demand side, we want to make sure that we'll get the energy consistently, and we want to also conserve the usage of the energy. And overall, in fact, there's a very dynamic change in the environment. In the energy market, I think a lot of you have noticed that because of the trend of low carbon society, so a lot of traditional energy generation methods were quite, or still are quite polluted. So they try to avoid using coal, gas, all these fuel-based, fossil fuel-based energy source. And they are turning gradually to renewable energy. However, I think all of you know that renewable energy rely on the weather condition. If it's a solar energy, it depends on whether or not we can get enough sunshine. If it's wind energy, it depends on whether or not we can get sufficient of wind. But wind cannot too strong either, because if it's too strong, then it will damage the wind turbine. So renewable energy supply becomes unstable. So when we say that from the supply side, they want to supply the electricity stably and efficiently, they need to have a way to ensure that can be done. Traditionally, it was quite, well, it's still complicated, but it's easy because they hold all the key of supplying the electricity. You just need to have the capacity. So they build up the capacity. And when they see tomorrow it's going to have higher demand, then they sort of get prepared. And the second day, they can cope with the situation. So they can always manage the supply as long as they make sure that all the lines are up and running. There's no fault at any place, so they can provide the supply. Now they have a big problem in Taiwan. By 2025, we claim that we're going to have 20% of electricity come from renewable energy. 20% is a very big number, but it could be 0 on one day and 20% on another day. So such a big gap from the supply side is very difficult to cope with. They don't have that much capacity already. So they need to somehow know what exactly is a shortage, and they can decide how to cope with the problem. One issue is all the existing methods, other than nuclear power, which Taiwan decided to abandon totally. So there's all other methods are more or less having some pollution. So you don't want to overproduce using traditional way because they have pollution, but you definitely don't want to underproduce. Then you will crash the power grid. You have difficulty you are causing a lot of damage for the factory, for the household, and so on. So from the supply side, it becomes very complicated. The demand is unknown. The supply now is unknown either. And from the supply side, of course, renewable energy is the new major player in the energy system. another issues will be trying to store the energy when we have more power from renewable energy, or when we have more power generated by power company. Maybe some people like Tesla, like Gogoro, they have a lot of batteries. Maybe like household, maybe like renewable energy farm, they are willing to store the energy in the battery, so that those stored capacity can be used to support balancing or stabilizing the energy supply. And of course, renewable energy generation has costs involved. Energy storage has costs involved. So how to optimize the strategy, the policy, the operation, so that the cost can be reduced to make our energy supply or electricity supply not just stable, also economically viable. Okay, but from the demand side, okay, traditionally it's already quite unstable. Now we also have a major actor entering the picture, that is electric vehicle. Once we have electric vehicle, imagining everybody drove the car back home in the afternoon. Everybody started to plug in and try to get their cars charged. For sure, it will crash the main grid. So what should we do? So there needs to be a big system to cope with that kind of demand. So the energy market become very dynamic, and energy system become very dynamic. So we need to have, just like what I said earlier, we need to have some data so that we can know what happened and we try to cope with the problem. Okay, so I'll talk about some cases so that you know. But to begin with, I'm just going to tell you that the grid is very complicated now, and managing the grid is something that power company has not been doing. In the past, they just focus on distribution. Now they need to have a lot of IT people helping them to gather data, analyze data, coping with all kinds of problems on the supply side. On the demand side, we need to have energy management system. Could be building energy management system, could be energy management system for the community, for the city, and so on, so that we can shift the load, or we can continuously lower the energy consumption from the demand side. So there are many problems mixed together, and which makes the smart energy area very interesting and very challenging. Incidentally, there were two people mentioned about electricity, reference electricity with, compare electricity with AI. Both of them say that AI is the new electricity, or AI is more important than electricity, which is also quite interesting. In fact, we are using AI in the electricity management area. Okay, so combining these two, you can imagine that using AI in electricity could be a very important area to explore. There are a lot of research topics and a lot of opportunities on the technological part, IT part, and also on the management and marketing, not marketing part, the financial part. Okay. From the demand side, we have been doing some research. This is the structure that we think can help the demand side. That is, from the beginning, we need to have all the right design of the products, the buildings, architecture, all the hardware solution need to be well designed, that it is energy efficient already, like air conditioner. It should be like eco-friendly. It should be quite energy efficient to begin with, right? For the building, you should have the right insulation. You need to have good ventilation. You should have, for example, you can have a pipe going underneath underground and coming up, so that the air coming indoor, go to the pipe. So even if the air is hot outside, when it goes underground, because it's cooler down there, when it comes out and enter the room, it's a lot cooler already. And you can have shading. You can have this detached facade, allowing air to flow between the facade and the building itself. And you can have, say, a coating, which can reflect lights, maybe absorb certain frequency and reflect the lights, the sunshine, all the way through the cloud to the outer space. There are different technologies that can be used to prevent the needs of consuming additional energy. So that is the hardware part. Okay. In terms of the smart part, still we have lights. We have like LED lighting. But when I went out the room, the light was still on. Maybe we should, if this is the place where people still don't go through, for example, hallway, maybe even in the toilets, those places where people don't often go there. But when they go there, they can trigger the sensors and lights will be lit on. But when they're left, there's no motion, the light can be turned off. It seems to be a little bit complicated. Why don't we just have a switch? Well, because people seldom help to switch on and switch off. That's probably the case. When I go out, and because I just go out for a while, I probably won't do that. I will just go out and come back. Okay, but anyway, there could be a lot of smart solution that we can use. In some system, they require that we need to expose the energy consumption data. Okay, so that we can know how to manage, how to improve. In terms of the smart solution, if we don't have data, in terms of energy conservation, if we don't have data, we'll be just guessing, right? Can we further reduce the energy consumption of this building? We don't know, because we don't really know how electricity are being used in this building. We only know the total consumption, maybe every month. And how do we know that it's better or worse? Of course, we can always do the benchmarking and say, oh, this building consumes more than the other based on the per square area, but they could be quite different depending on the usage, right? And different issues. So if we can have more measures, then we should be able to utilize the data and having a better analysis, knowing which part is more likely to have energy conservation or energy reduction, so that we can perform some improvement. And it can be done. It has been done by many people too, but there are still room for improvement. Of course, we know that air conditioning is probably the most energy consuming more energy than any other equipment in indoor. Lighting is probably the second one. The third one, in a lot of places, it could be elevator, like people mover. Then they have also waste. Or elevator, we can have better control policy. Later we'll see. We can also have energy harvesting technology. And in some other buildings, for example, in hospital, water processing is one of the main energy consuming entities. Okay, so these are different things. If we want to improve, we need to know what happened before we can do anything. So earlier I mentioned that here on campus we have done a study on reducing energy consumption for water dispenser by changing its water processing policy, so that for different places they will have different amount of water or different amount of water for different needs. Boil water, warm water, and cold water, right? Outside stadium, for sure, cold water. People will exercise. Probably nobody will drink hot water. Right? Outside the offices, it will be different. Outside the classroom, it will be different. Outside for, say, student lab, it could be different. And those systems can learn by recording the usage, learning by themselves, and changing their water processing policy to conserve and to reduce energy consumption. Okay, so that could be one thing. That is something that we have done. A lot of people did this HVAC, heating, ventilation, and air conditioning, HVAC, energy conservation, because it consumes a lot of money. You probably in Taiwan, okay, in Taiwan, the electricity rate is probably one of the lowest in the world already. It's 1 kilowatt hour, about 2 point some NT dollars. For a bigger room, bigger, I wouldn't, maybe it's not room. Last weekend, I went to an organization. They have an entire floor. So I shouldn't say that it's a room. I don't know how big it is. It's quite open. Every month, they need to spend more than 300,000 NT dollars for electricity bill. So you multiply that for those of you who have been in 101 building, 101 mall, for each month, it could be millions of dollars just for electricity bill because they have air conditioning. So air conditioning, energy conservation is the main, the key research area. And also, I mentioned that a lot of places have this energy management system. On campus, through a smart campus project, we started to install quite a few sensors like electricity consumption meters at different places. Some are finer, some are very rough for the entire building or for entire floor. For each floor, it could be air conditioning, lighting, and the rest of the electricity consumption. So basically, based on the situation, we can collect how electricity was consumed in different buildings. And then we can devise different policies, right? Different policy, or we can identify anomalies and try to fix the problem. Maybe there were air conditioners having problems and consuming too much electricity. Maybe in some rooms, they always open the windows, open the door, and hot air kept coming in so that they consume more energy. Maybe there are other issues resulting the waste of the energy. So all these issues may be identified and fixed. And a lot of big buildings, they show that they can reduce the energy consumption easily by 20%. I think on campus, if we do a more detailed analysis for our campus, which is a very heavy user of the energy, I think we can easily also reduce 20% of energy consumption. However, it may create some inconvenience and different things. So to implement it does require some effort. Further down, we have all the smart solution, but further down, these smart solution can be overwritten by human. Right? I have a sensor, but I don't think you can just force me to activate the sensor. So I'm sitting here reading, suddenly the light went off. So what I'll do is I will inactive, well, that function so that when I turn it on, it will just stay on. So human still override the system. So what we have been doing as well, like some time ago, it is when Indy was here, we have been doing this so-called persuasive technology, providing data, feeding back to people using gaming, or well, to begin with, just just providing feedback on energy consumption on individual. So you see your energy consumption, and maybe we'll let you benchmark other people's energy consumption, and you can see that you consume more than others. Maybe that will create some effect. And we can allow you to set a target so that you can set the target, say, okay, I'm going to reduce 10% of my energy consumption. And you can track your usage so that you can adjust your behavior gradually, rather than not knowing whether or not you do a certain thing, whether or not there will be any effect or not. So getting feedback in a lot of cases, in some European study around at least 5 years ago, when I was in Switzerland, they did a lot of such kind of study and showed that just by feeding back to people, for those people who have intention to conserve energy usage, it will generate about 10% of the reduction. That was based on Europeans, or maybe just Swiss and Germans. But basically, if we can have the data, using the data to influence people's behavior, and they may be able to help with further reduction of the energy consumption. So hardware need to be redesigned. Hardware need to be redesigned to begin with. Hello? Hello, hello?
Yes, we can hear you.
Oh, okay, sorry. So it just showed that there's a problem. But can you see my PPT?
Yes, I still can see it.
Okay, then I'll leave it that way. From my side, I couldn't see my PPT.
Oh, okay.
Uh,
Is it the energy efficient technologies slide?
Too smart. Yeah. I may need to quit and come re-enter because I couldn't see my PPT. I couldn't control. Okay, sorry. Let me try. Okay, it's back, right? Can you see me?
Yes.
But it keep jumping. Okay. Okay, maybe I'll leave it this way. So so persuasive technology is a whole system of functions. In Switzerland, all the power companies are using persuasive company to help their customer to reduce energy consumption. But why will a power company helping their customer to reduce energy consumption? Well, by using less electricity, they will lose money, right? They will lose their revenue. But the reality is the demand fluctuates. In order to cope with the peak demand, which is rarely happen, the power company need to increase their capacity to meet the demand. So rather than increase the capacity to meet that kind of demand, they are willing to pay or reduce their revenue by convincing their customer to reduce their power consumption, so that the power company does not need to invest heavily to increase the capacity to cope with that additional demand. So that is still the strategy, right? Reducing the demand. I think power companies nowadays, they like you to consume less energy, because when everybody is power hungry, when they don't have any control, in the worst case, the demand will be way too much that the power company cannot cope with. So that's the situation. And I mentioned about many technical way of doing that. One is for air conditioning. Imagine that during the summertime, when indoor you have air conditioning on, when your airs are going out and you are extracting the air from outside to be processed. In between, you can allow this heat exchange so that the entering air can be cooler before they are being processed. Heat exchange are in a lot of equipments nowadays. I think even 6-7 years ago, when I visited a lot of energy efficient building in Germany, they have such kind of system installed already, and it will reduce the electricity required to process the air from hot to cold to cool, right? Because of the heat exchange. And for lighting, is the easy solution. You just need to change the traditional light bulb to LED lighting, and you will have significant reduction. Of course, you can add more smart functions so that it can automatically turn off and turn on and so on. You can further reduce the energy consumption. I mentioned about elevators. Elevators usually run with one person going up, one person coming down, and different people are just taking these elevators at will. I think we have done a little bit of research on that, although we haven't really been able to solve the key problem is knowing how many people are taking the elevator at which time and so on. But the general principle will be knowing how the elevators are being used and changing its control policy to conserve energy. Okay, but we cannot sacrifice too much of the customer service level. But I think just like water dispenser, the elevators are used for under different circumstances. In the morning, all the people came and try to go to their offices. So chances are every floor they need to stop. But if you go through the 10th floor and every floor you need to stop, then you have too many stop, go, stop. It's very slow. So they divide it into 2 elevators. One go to us floor, one go to even floor. Okay, that makes sense at that time. But then maybe it shouldn't be up floor and even floor. Maybe it should have certain floor and the rest of the floor, if we know the usage. But during the more like idle time, I saw a lot of situations where people come, they want to go to the odd number 4, and there's an even number elevator there, and they will still press a button and ask the odd number 4 elevator to come down and take that. That's a waste of energy consumption. Okay, and also mentioned that when elevators are moving, they need to have this counterweight to stop, right? To put the brake on the movement. That counterweight, when they are stopping, in fact, they can do energy harvesting, right? You can imagine that there's a kinetic energy. You want to stop it, so you can harvest the energy. So elevators can have this energy harvesting mechanism. So not only changing the control policy, and you can also harvesting energy. And earlier we saw this NTUST thermostat or micro climate controller or home temperature controller. It can learn, and basically NTUST use a reinforcement learning to learn the behavior of the users, and gradually will adapt the control of the temperature automatically based on the historical data. Okay, using reinforcement learning. So that is also a smart function for controlling and making the temperature more suitable for user, but not overheating or underheating, or not overcooling or undercooling. Of course, it will not be 100% accurate, but it will adjust automatically based on the situation. Otherwise, the problem is when I go home, too hot, I turn it down. Later it becomes too cold. It's okay. Too cold for 10 minutes, 20 minutes, or half an hour. Okay, it's really too cold. So I adjust the temperature back. So again, it will have some effect, but not definitely it's not like 100% reduction, but it will have some effect. And if we think of the application of such kind of measurement and improvement, you can find a lot of places where you can try to reduce the energy consumption. And here is an example on retail. In fact, it was a study on Family Mart convenience store, and these are the equipment that they have in the store. And if we can monitor them and identify problems for them, helping them to reduce energy consumption, they will significantly reduce energy consumption. And usually the control is not that straightforward. It's not like, oh, the light is on, it should be off because it's 5 o'clock. There's only one consideration. Sometimes at 5 o'clock, it should be off. Today at 5 o'clock, like right now, it shouldn't be off because there's an embed there. But it could be the outside is very, very dark, so it shouldn't be off. But if the outside is extremely bright, maybe it should be off. So these conditions are quite complex. So a good way is having a semantic to represent the relationship of the condition. So there's an organization focusing on energy efficient building. They are collecting all the ontology on different cases so that they hope to combine them to provide a more comprehensive framework for doing smart control of the electrical appliances indoor for energy efficient building. Okay, so usually semantics can be used for. Here I was referring to energy efficient building. In a factory, it can also help us to deal with complex event processing. And we have done a little bit of work on this, but haven't really pushed through such kind of framework in a more comprehensive way. And this is the persuasive technology that I described. The framework doesn't come from us. Persuasive technology was proposed by behavioral scientist or psychology professor at Stanford University. And he has a framework on motivating and in terms of capability. He has a big framework and people follow that framework and building up a lot of scenarios for persuading people to change their behavior. Okay, so I will not go in detail. I think we can do gaming with yourself, gaming among your peer, gaming between different rooms, gaming between different buildings, because human behavior is very irrational. So basically, you need to find way to cope with the uncertainty. You need to find motivation, or you need to deal with the inability to fulfill their commitment. So IT is a very good way to do that, right? Making everything easier, reminding all the time, providing a game for them, providing a competition for them, and people will be triggered to do certain things or change their behavior. The point is, just like persuasive technology in we call it health promotion, helping people to improve their healthy lifestyle. Unfortunately, is people who are healthy never thought that they will get ill. So you need to find different way to motivate them. So similarly for energy conservation, you need to find different ways to motivate people to reduce their energy consumption. And there are different ways that we can do. And blockchain can also help for electricity distribution. As I said, electricity distribution becomes very difficult. In the past, it's just power company distribute the power, taking the consumption on the meter every month and charge you. Now it's not like that. You could be a consumer, and you could be a producer, and your neighbor is a consumer, and they can be a producer. So in Taiwan, the energy market has been opened up, meaning that a lot of people can become producer. They can contribute the power that is generated through renewable energy. And they will also sometimes need to buy electricity, maybe from the main grid, but they could just buy the electricity from their neighbor, so they can exchange their energy. So energy consumption, if you cannot record it, you cannot deal with the payment. That is very difficult to allow them to freely exchange energy. So you can utilize blockchain, record the consumption, automatically trigger the transaction. And in fact, you don't need to have money in the system. As long as everything is recorded precisely and cannot be altered in the system, when anybody want to exit the system, they need to be cleared. Okay, at that time, it depends on whether or not they are owing money or they have revenue from the exchange. They can be cleared when they want to exit. But before that, they are all in the system, and they will be exchanging the energy all the time. They don't need to have actual financial transaction. So it will also help the exchange of very small amount of electricity, and all this information can be recorded on blockchain. As I said earlier, blockchain, once the blockchain store the data, it's almost impossible to change. Almost. Okay. And there were quite a few projects or pilots. Brooklyn microgrid project did the things that I just described, but it could be a little bit difficult because some come from main grid, some come from your neighbor. Maybe you have solar panel, they have wind turbine, and sometimes you supply to them, sometimes they supply to you. All of them can be recorded, and every time you use your neighbor's electricity, and you need to transfer a certain amount of cryptocurrency to them, all of them will be recorded on the blockchain, and the transaction will be triggered by smart contract automatically. And similarly for electric vehicle charging, the main problem is if you are swapping the battery. Okay, you have your battery, you are swapping the battery, or you charge your battery, you are depleting the lifetime of the battery already, meaning that the value of the battery will be lower. All this information need to be recorded so that in a certain occasion that you want to swap the battery, maybe your battery is quite new. The new battery, although fully charged, is quite old already. Once you swap them, your battery value decrease. Okay, so that kind of differences can be compensated through the use of blockchain. Blockchain will record the remaining lifespan of all the battery, and whenever there is a swap, blockchain with smart contract can compare their remaining value and do the compensation for the party which lose money from the swap. Okay, there's a system out there as well. And for the power system, there are a lot of problems. Basically, it's just lots of data, hard to understand, and very uncertain. So using IoT and with the AI can help to deal with a lot of problems. Even in manufacturing, we talk about predictive maintenance, or in manufacturing, we talk about forecasting, of course, power system control and transmission line problem detection. All these things can be done with IoT and also AI. And predictive maintenance, just like in manufacturing, this is a wind turbine, turbine hub. So the bearing is will wear out, and so basically we need to detect the potential problem. And usually when temperature is getting higher, meaning that the rotation is not very smooth. So there's an unusual rise of the temperature, you know that there must be something wrong, and you can try to interfere. Otherwise, when it gets too bad, the damage will be even bigger and causing a lot bigger damage. Wind turbine, we have research on wind turbine power generation, and we are trying to do a wind turbine maintenance optimization as well. It's a very complicated problem, but it's very challenging, but it's also extremely profitable. Okay, in terms of if you can better manage your maintenance. This is another case of the gearbox, turbine gearbox. Again, you can just look at the data, detect anomaly, which indicates that in a certain amount of time that the potential breakdown may occur, so that you can schedule the maintenance in time for the maintenance. Offshore wind turbine maintenance involve not just routing, right? Traditional routing problem. Offshore wind turbine maintenance involved, if the weather is bad, for sure your boats cannot go on for maintenance. When the weather is good, meaning that the wind is very good, you won't stop the wind turbine for maintenance, because we calculate very roughly with a 2 megawatts per hour, 2 megawatts capacity wind turbine. Stopping for 24 hours is already $500,000 NT. So if you stop it for maintenance for 1 day, without the right cost, you are losing $500,000 NT. So it is, and wind turbine is still quite expensive. Although the price has dropped tremendously, but then still for 2 megawatts capacity wind turbine, it's about 100 million NT dollars, which is about 100 million, right? 100 million, okay, yeah, 100 million, like $3 million US dollars, $3 million US dollar, more than $3 million US dollar, just for one wind turbine. And life cycle costs and operation and maintenance costs for offshore wind turbine constitute about 40 to 60% of the life cycle costs, meaning that if the wind turbine costs that much, the operation and maintenance cost about the same amount. So if you can reduce the maintenance cost, reduce the operation cost, you can significantly improve on the profit of the wind turbine, of the use of the wind turbine. Okay, so that's smart energy part. I sort of give you some picture on the potential problem. There are a lot of smart energy research being done. There are different companies in Taiwan doing different kind of research. We have a relatively good big group in the lab, but in the school we have quite a few groups working on smart energy related research. The last issue that I want to talk about is about smart transformation. I think a lot of, up until recently, we focus more on the economical benefit of all the system. But more and more, we are considering the sustainability issue. as I mentioned, I think 2 weeks ago, that sustainability is no longer a like moral thing only. It has some tangible cost because of this carbon neutrality goal set by all of the country, a lot of countries in the world. By 2050, we want to reach a carbon neutral society, which is about 30 years from now. But in reality, by 2030, we have to stop the growth, continue growth of the carbon emission. So our goal is within 10 years, now there are only 9 years, we need to stop the growth of the carbon emission so that we can start to reduce the carbon emission. The reason is to the research, they found that if by 2030 we cannot stop the growth of the carbon emission, we will have passed the point of no return, meaning that it will overshoot and it will never be able to come down. In terms of the money you spend, in terms of the potential technology that will be developed over the next 30 years, you will not be able to pull it down to carbon neutrality. So our goal is within these 10 years, trying to stop the growth of carbon emission. So there are a lot of activities are being done. I mentioned earlier, a lot of things are being done. Electric vehicle, a lot of countries will start to ban fossil-based powered vehicles on the street in the future. A lot of countries are trying to utilize as much renewable energy as possible. In Germany, I think it's already over 50%, maybe even 60% of their electricity comes from renewable energy. Okay, but that may not mean too much for a lot of countries or for Taiwan, because in Germany, the surrounding country all have nuclear power. So they can say, oh, we are going to use renewable energy. If we have shortage, we buy electricity from other countries. So we don't want to pollute our environment, but and we don't have the risk of having nuclear power plant. But our neighbors, friendly neighbors are very happy to sell our energy at a premium price. But that additional energy provided by the neighbors can help them to stabilize their energy supply. But for Indonesia, do you have that kind of neighbors close by? For Taiwan, do we have that kind of close by neighbors? At least for Taiwan, we don't. We are just an island. So everything that we have comes by ourselves. So that is a very difficult situation for us. At Singapore, up until now, Singapore doesn't seem to have an intention to reduce carbon emission. They have no intention to meet this carbon neutral society because it's not possible for them. It's just a small spot. It's very difficult not to use energy unless their neighbors are extremely friendly, which may not be the case. So they will probably try some other way to compensate their carbon emission. Okay. And because the IoT business model are finer, no longer very rough business model. A lot of things were closed, now open. A lot of time we are just getting data. Now we are trying not just getting data to know, we want to predict, even prevent. We are talking about aesthetic in the past. Looks good, looks nice. Now we are talking experiences. Experiences differ from people to people. So for sure, you need to have data. In the past, we were very business oriented. Now we should be customer oriented, which is very difficult. Customers are very different. We were talking about share of market, very static. Now we are talking about share of life. Like this customer We want to get a share of their life. We want to serve them, these customers for their entire life, and how long of the time spent that we can serve them. All of these, you can probably tell that it requires something to get data from them, right? Being with them so that we can understand them more. We can have contact with them so that we can know them and we can serve them. So all of them imply that we are using this technology-enabled, data-driven approaches to change the paradigms. And these are some of nice cases. I found them very interesting because I also did a construction automation talk some time ago. And see, they have a platform. It goes up, and people from the platform are building this building. And this is a robot stacking the brick precisely as we design. A human cannot do that. A robot can do that. And there are different kinds of technology you can probably see. And these are this building is in Shanghai, and it is exactly as I described. They use robot to place the brick precisely at the location as designed. Okay, and some of the very complicated shape, robots can now do that and create this very art-looking architecture. And here, robots are moving along from two sides by themselves, building on the bridge. Also quite interesting. And business model are changing. Okay, and we can even have something called outcome economy, which is also something we are working on in our lab. That is changing the product selling business to outcome selling, supporting circular economy. And a product selling business is a very polluted business, overproduced, planned obsolescence, overproduced to the extent that you wouldn't imagine. Just think of athletic shoes. It's based on a shoe producer's information. He said that if every person needs one pair of shoes every year, right now in the world, we are producing 2 pairs. You can imagine that this additional pair doesn't have utility, and they were produced because the more they sell, the more they profit, right? So by having this outcome base, we did not transfer the ownership. So the planned obsolescence, overproduction, we may be able to stop the overproduction and planned obsolescence practice and contribute to circular economy, that is prolonging the lifespan of the product and reducing the waste or the carbon emission of the traditional product selling business. And there are a lot of business model are changing. Okay, maybe go to coffee shop. Coffee is free. You want to buy the seats, buy the table, rent the table. And a share economy is one very prominent example. And in fact, if you analyze more detail, I don't have. There's picture. I think after the pandemic, basically we see a lot of changes, and we see this is last year in July. From the start of the pandemic until the time, they found out that under that kind of circumstances, the growth of different industry, which rapid growth of certain industry is very different from what we expect. You just look at Amazon. During that period of time, maybe half a year, 401 billion increase in their revenue. My understanding at that time, just Jeff Bezos alone, his fortune increased by 20 billion US dollar from the pandemic, 20 billion US dollar. Maybe I was underestimating that number. Maybe for sure the number is even bigger. So it's a very different world. Whenever there's major event. They call it Black Swan event. And you can look at the slide, understanding different technology, different industrial sectors having different impact to the pandemic. I guess I don't have enough time. I want to pause here. So we are developing this outcome-based model, and we spend a lot of effort trying to make it clear to others, trying to facilitate this model with technology and financial model, building up their technological feasibility and financial feasibility. Technology feasibility using IoT, blockchain, and AI to support its technology feasibility. And financial feasibility is analyzing the new pricing scheme, allowing manufacturers and also customers both benefit from the cooperation. And it does contribute to SDG, United Nations SDG, in many aspects. And for carbon emission, we can also do something as we did for energy consumption. And for digital transformation, I think it's not just about hardware. I think this is a comparison of the digital industry. In Taiwan, digital industry contribute almost 20% of our GDP. But out of this 20%, only 16.6% come from digital services. Okay, 84%, around 83 to 84% come from hardware. But in the US, digital industry contribute about 10%, 11% of their GDP. And out of these 10%, 91.5% come from digital services. So it is to say that digital transformation help us to provide digital services based on digital technology. It has a very wide room for improvement, even in Taiwan or for other countries. Okay, I think I will stop here. And we still have 5 minutes to entertain any questions. Laura?
Thank you, Professor Chou. I remember as well when you visited Nottingham last time, that is also for the smart energy. And we take, you take a look at this smart energy building in the campus area.
Yes, and it was very nice seeing you there.
Nice to see you too. Okay, so we have 5 minutes to questions and answer sessions. Is there any questions from the participants before we will have the final evaluation? There is one question. I will read it to you. So the question is from Ahmad Muslim, and he's from the Department of Information Systems, and he wants to ask about the blockchains in the work of electricity. So as we know that using of cryptocurrency have energy issue in the process, and it requires a lot of energy because the computer need to ledger all the transactions and usually says as miners. So how can this blockchain implement the energy efficiency and solve that energy issue?
Okay. The blockchain contribution will be mainly for recording these energy consumption and transaction. First of all, I must say that it's a very good question because point out the problem of blockchain. We all know that blockchain, particularly right now, Bitcoin is consuming a lot of energy, and of course there's some proposal of changing the mining process. Also, the second most important blockchain, Ethereum, their newer generation also focus on reducing energy consumption. I guess blockchain has many types with different security level. The more secure you want, the more secure you want, the more energy it will consume, which is probably quite reasonable. For a lot of application, it doesn't have to be that secure, because it is just like bookkeeping. If three of us are doing something, we want to keep a record. It doesn't require like a supercomputer or whatever ways to keep the data, right? In the traditional situation, it's also like that. It's something more and more critical. The amount is bigger, then we'll put it in the safe, or we'll put it in the safety box in the bank. We'll transport it in a certain way. For some of the applications, when it is not as critical, I think the energy consumption based on the blockchain will not be that much. It doesn't have to be a how should I say? It doesn't have to be a public chain. It can be a consortium chain. It could be a private chain. When it's private chain, it is just like redundant storage. It is still quite difficult, more difficult to breach. But then it does have certain characteristic of blockchain, but it is not a full-blown public chain where you require people transfer millions of US dollars, which cannot have any errors. Okay, so the question is valid, but my answer is that I don't know exactly I did not analyze precisely how much money, how important or how much transaction it will have to be so that it is financially viable to use blockchain. Okay, but I can tell you that private chain doesn't consume a lot of energy. We can just have like 3 computers, independent computers, recording for a lot of transactions. And 3, I mean, even for us, like cracking down one blockchain is probably already quite difficult. And there's no financial incentive for those big hackers to hack into our system. And there are different ways to do that. We don't need to record all the information. For our application, we don't need to record every information, every transaction. We can just, there are also solutions that they sort of save it in some database and building a Merkle tree, and they have a hash, the hash key on the root, recording the hierarchical hash value. So you store the hash key onto the blockchain. So after many transactions, you store just one record, and you just need to authenticate the rest of the value in the Merkle tree or the hash key tree. So if you found out that they haven't been tampered, then you can trust the value. But you can probably have thousands or tens of thousands of transactions before you store the value onto the blockchain. So it depends. So that kind of mechanism is also available. But as I said, private chain can also be used to reduce energy consumption.
Okay, thank you, Professor Chou, for answering the questions. So we ready to start the final evaluation. Professor Chou can have a break and join us again in 1 hour. Okay. And I also want to greet Professor Erma, who already joined the...
Hello, sir. Sorry, sir. Oh, okay. I just came back from other activity. Yeah.
No problem. No problem.
Thank you, sir.
No problem. No problem.
Yeah.
It's a pleasure. A lot of you.
Thank you, Professor Erma, for attending the sessions. So
thank you, Budaras. Yeah.
Give this time for Pak Indi to deliver the final evaluation.
Hello.
Okay.
We can continue and then close this session. Yeah, Budaras. Yeah.
Okay, so everyone already submit the final exam. I would like to remind you for the mini projects. Do not forget to submit. So you have 3 days. You still have 3 days to submit until the due date. And the closing, there is one representative from participant who would like to share comments about the lectures. We have Ben here. So please say something, Ben.
Oke, thank you Bu Raras, Prof. Erma, Pak Indi, dan Pak Muja, and especially to Professor Chou. We are very grateful that you have filled this lecture for 6 weeks. It is really fun for us, and then it is eye-opening, especially to a new technology like digital twin. It is quite a buzz, yeah, because we talk it over our group chat about it. And then the other IoT application, because as we know, in the future there are a lot of possibility, especially in Indonesian market. We hope next year there are also a demonstration about the tech online. It is from us. Thank you. I give back to Ms. Laras.
Thank you, Ben. Thank you so much. There's also another comment from Nabila Anissa, but because she have breaking the fast, so I will read the comments. She and her friends in the Rising Sun mini project group would like to thank to Prof. Chou, who has provided material for about 6 weeks. I hope that the knowledge can give them to be applicable in their lives in the future. So big thanks to you, Professor Chou. So that is all from the participants, and I would like to give opportunity to Professor Erma to closing statement.
Yeah, thank you very much, Professor Chou. Yeah, Mas Indi, Bu Raras, Raras Tias Nurita, Raras Maya, and Bu Ika, as all the moderators here, and also Pak Mujahidin. Yeah, we hope that we can have like this course again for the next semester. Yeah, with the new topic or probably the advanced topic of this topic. Yeah, the development of this topic. Yeah, we can have this opportunity for the next semester. Yeah, to let Professor Chou give another lecture. Yeah, probably for 4 to 6 meetings. Sir. Yeah, yeah. Thank you very much, Professor. Yeah, we can see you next semester with the new topic. Yeah, thank you, Prof. Yeah, thank you, Bu Raras. Yeah.
Thank you, Prof. Erma.
Prof, you still mute.
Oh, yeah.
Right. So I also would like to give opportunity to Dr. Mujahidin, Pak Muja. Silakan.
Okay. Thank you, Prof. Chou. I hope we can meet again at next semester. IoT that topic can be useful for us. Thank you very much, Prof. Chou. See you again next semester.
Thank you, Pak Mujahidin. I think that brings us to the end of the lecture. We will take a picture for sure. But before that, I'd like to finish with this inspiring quote from Alvin Toffler. The great growing engine of change is technology. So hopefully all of us can join this lecture. Who joined this lecture are the agent of change for the better futures. We sincerely appreciate all participants for your great attention. Thank you for listening and have a good day.
Yeah, thank you very much, Bu Raras. Yeah, thank you, Professor. Yeah, see you next semester, Professor. Bye-bye.
Yes,
yeah.
see you next semester.
Yeah, thank you, Mas Indi. Yeah, Bu Raras,
Ya, makasih
Pak
Bu.
Muja. Yeah.
Kasih Laras,
All the
Pak
audience,
Muja.
thank you so much. Yeah.
Thank you, Indi.
Thank you, Prof.
Thank you, Rara.
Yeah, thank you.
Take care.
Yeah, take
Thank
care.
you, Emma. Okay.
Yeah, thank you.
Okay.
Bye-bye.
Yeah. Okay.
Yeah.
Bye.
Bye-bye, sir. Yeah.
Bye.